Hey everybody, let's take a quick look at regular expressions. We've already done a lot of this in class, so it's familiar to you. The regular expressions are just templates to match certain patterns inside a string. So if you have a string that contains the word Bucky in it, somewhere in lowercase, then this pattern would match that string. This is the PHP version of how we can check to see if something matches. We put a pattern here, then a string to check, and then optionally there's this third parameter that will return any of the matches. Now I'm not going to require that you have a knowledge of this function. We're going to take a look at regular expressions more from a theoretical standpoint, and in fact we have a nice JavaScript tool that allows us to test for regular expressions. So don't feel like you have to know what's going on here, but do understand that we test a string for a certain pattern. And typically the patterns are delimited with a slash. So we'll take a look at examples as we go forward. All right, so here's an example using the preg match. Matches are either true or false, and so we have this pattern //ava, and in PHP we also have to put it inside a string. So the string which has the pattern of ava, and we're going to check it against $str. So does yabba dabba do match? Well, in fact it does. It matches here, ABBA, and it also matches here, ABBA. And one of the things, and I'll just kind of verbally express this, with regular expressions is as soon as it finds a match, the regular expression is happy and it returns that match. So in this particular example, let me see if I can bring up my tools here. Yeah, didn't work out too well. Try again. It's this ABBA right there that gets matched. Not the Y, but the ABBA. Right? So regular expressions always look for the first match it can find. And also it tries to match as much as possible. We'll see that later on when we start talking about quantifiers. Okay, good. So we got that. I love the music of ABBA is not going to work because matches are case sensitive. So ABBA with a lowercase a doesn't match that. Right? So you can use preg match inside if-else blocks because it will return either true or false depending on whether a match was made. All right, we talked about this in class. Make sure you understand that. Okay, so metacharacters are it's not like an A or a B. It's representative of more than just a single entity. So let's just take a look at examples. The first metacharacter that I want to talk about is the dot metacharacter, and it stands for any single character. So any one character is matched by a dot. So the pattern PE.L will match PL, PE, any character, and then an L. PE, any character, and an L. Again, same there, but not these. And you can verify that. Here's a P, but then there's no E after it, so immediately it fails. Here's a P, an E, any single character would be an A, but then there's not an L after it. In fact, that would be an R. Right? How about ape-like characteristics? Absolutely. There's a P, an E, any character, and an L. All right, so the dot represents any single character. And if you really want to match a period, you escape it with a backslash. Let's go to the next one. Simple quantifiers. So now we have these patterns, or these potential, like the dot or the letter A, and we can quantify it. So the first quantifier is the star, which means 0 or more of the preceding element. So FRE star D is an F, an R, and then 0 or more E's, and then a D. So Fred matches. That's an F and R and 1 E. Freed, F and R and 2 E's. FRD is FR, 0 E's, and a D. So each one of these matches the pattern, but neither of these match. And the 0 or more can get confusing, but if you practice with it, it's pretty easy to do. So we have the star operator, which is 0 or more. There's a plus operator, which is 1 or more. So 1 or more of the preceding element. In this case, it's FRE, and then 1 or more D's. So these match. but not free, obviously, because it's an F, an R, and E, and now it's expecting at least one D, right? So the plus is 1 or more, the star is 0 or more, and you can group things in parentheses. So FR and then parentheses ED means an F and R and then 1 or more of the string ED. By the way, this doesn't match. This is an error. That should be a lowercase f for this to work. And then finally, to finish out quantifiers, the question mark is 0 or 1 of the preceding item. And a question mark also removes greediness. We'll take a look at that in the example section here. A to B matches between A and B inclusive, so you could do something like 1 to 5, or just 1 or more, or exactly 5. All right. So here's an example. \d parentheses 2 d or \d means any digit, so \d2 means any 2 digits. So 2, 3 matches because it's exactly 2. 344 matches because there's a 34. And it always tries to find, it'll always return the first match, and it always tries to match as much as possible. So, but it's not going to return 1. We'll take a look at the greediness in a second also. And this is pretty simple. Alternatives, so Fred or Barney or Wilma. Character classes we also looked at in class. Just to keep it simple here, this character class, noted by the square brackets, means any single character that matches anything inside those brackets. So any A, B, C, D, E, or F would match this pattern. And you know what, I think maybe this is a good time to kind of jump to the example. If you go to the week 15 folder, there is a reg expression tester. And it looks like this. And so let me just type in Yelp. And then we type in a so this is the string that we're going to check to match. And then a regular expression. Let me close this down for a second. So A, B, C, D, E, F means any single character that matches either an A, a B, a C, or D, or E, or F. So clearly Yelp does match because there's an E. So if we submit it, it will show you down here what the exact match was. Let's do scalpel. Now what's it going to match? Well, again, any single character that matches A, B, C, D, E, or F, it will try to find the first one, which is a C. So it doesn't even bother getting to the A and the E, even though those match as well. It finds the first one, and then it quits. Another way to represent these character classes, as long as they're in order, is to put a dash in there. So that means the same thing as before. We still match a C. What do you think of A to F with a plus sign after it? Well, now it's going to try to match as many of those as possible, 1 or more. And by default, regular expressions are greedy. So given the opportunity, it will match as much as it can. But again, it only finds the first match. So in this particular case, a C and an A is going to be what it matches. Even if it can find more stuff down here at the end of the string, right? Clearly E, A is a bigger match than just CA, but it's still going to find CA because that's the first match it finds. So again, for regular expressions, the notion of greediness is find the first match and then match as much as possible. And that's what we're doing here. So you can take a look at this. I mean, these examples are pretty self-descriptive. 0 to 9 in a character class is any digit. And remember, we already talked about any digit. You can also represent it with a \NAD. So this and this, sorry about the handwriting, are equivalent. Okay, so these are some shortcuts. You should probably know what's going on here. \D is 0 to 9. \D is anything that's not a 0 to 9. And a word element is one of these. You don't have to memorize that. Just generally know that it's all the capital and lowercase letters 0 to 9 and the underscore is considered a word character, \W for word. \S is any white space. That would include just a regular space or maybe a new line return, a tab, right? And \S plus would be any one or more. We don't have to worry about this right now. You've already looked at anchors, and so let's just take a look at some examples here. I want to show you some more greediness examples, and then I also want to throw in the question mark. So back to this. By the way, as we've already mentioned, in PHP we use pregmatch. In JavaScript, and this is pure JavaScript, not even jQuery, if we have a string like A, B, C, D, E, F, and we want to match something, we just use the .match method, and then throw a regular expression in there. So let's do match C dot plus. What's that going to match? Well, it's going to look for a C, which is there, right? Then a character, then any single character, which is there, a D, and then as much of that match as it can find, so one or more. And so in this particular case, it'll find the C, D, E, and F. But my point here is that this is how you match things in JavaScript. So you give it a string, give it the match method, and then give it a regular expression. And if it doesn't match, so let me do the up arrow here. If it doesn't match, let's do X with a dot plus, right? Well, that's not going to match because there's no X in A, B, C, D, E, F, so it'll return null. Now, just so you're clear here, right, and this is where it gets a little tricky. What if I did this? A, B, C, D, E, F dot match dot star. What does star mean? 0 or more of the preceding character. Well, let me even do this. X star. It's a little bit more descriptive. 0 or more X's. So can we match? Does this match the string? The answer is yeah, because the string has 0 or more X's, right? And where does it match? It actually matches right there. That spot right there has 0 or more X's. So notice it doesn't return null. It returns an empty string. A slight difference, but the first one here, this example doesn't match. This example does match. And you just have to be aware that it's possible that you're matching emptiness. A little bit complex, but I think you can get it. All right, so let's continue with some examples. Apple sauce. And let's do an A dot plus E. What's it going to match? In fact, let's do this. Let's do P dot or dot plus E. All right, so it's going to look for a P, then one or more of any character, so one or more of any character, which clearly it has, and then an E, and there's an E. So you might think at first glance that it's going to match PPLE. But in fact, if you submit it, you'll notice it matches PPLE sauce. Why? Because we started with a P, we found a match, but then it says, hey, you know what, I'm going to take as much as it gives me. So here's a P, and then plus, dot plus can cover the rest of this part right here, because there's another E. So in this sense, it tries to be greedy, and in fact, it's successful. It grabs as much of the string as possible. Now, we can remove the greediness by putting a question mark after the potentially greedy quantifier. And we have two, right? We have a star and we have a plus. I mean, there are others, but those are the main ones. Those are the ones I'm holding you responsible for. So now a P dot plus, but don't be greedy. Just find your first match and be done with it. If you submit that, you get PPLE, which is what you might have expected in the first place. All right? So use this regular expression tester in week 15 to kind of play around with regular expressions and see what you can come up with. In the notes or in the tutorial section, I have some, I think I had a regular expression worksheet, and so now what you can do is go through that worksheet, try it out, see if you can get the answers correct, And furthermore, try to determine not just whether or not there's a match, but what the match is, and then you can test it against this regular expression matcher. Right? So I think that's good enough for this lesson, and let me know if you have any questions.